Can domain of a rational function be all real numbers? Well, whenever we talk about rational functions, we are saying a rational function, r of x, is ratio of two polynomial functions. Let's say p of x over q of x, right? So it's a ratio of two polynomial functions where q of x is not equal to 0. So that is the restriction. So this is the restriction, right? And because of this restriction, denominator can never be 0. We do have restrictions on rational functions. But the question is, will all rational functions have restriction? That is to say, can you have a function q of x which will not be 0 at any time? If your answer is yes, then we say, well, in that case, the domain of rational function could be all real numbers. And there are many functions where q of x may not be 0. For example, if I write q of x as equals to x squared plus 4, x is always positive. It can never be minus 4 to make it 0, right? So these kinds of functions will have no restriction, right? So my r of x could be, let us say, 2x minus 1 over x squared plus 4. Now this function has no restriction. Here the domain is indeed x belongs to real numbers, right? So you will come across so many graphs which will be graphs of rational functions and which may look like something like this. For example, like this. Do you see that? This kind of a function is a graph of a rational function, but it has no restriction, do you see? So that is what I'm trying to focus on. So there are cases where we have a rational function and it may not have any restriction. That means no vertical asymptotes, right? So there are no vertical asymptotes, right? And no holes, right? So these are the two restrictions which could be possible on rational functions. So we can have examples where we will have no vertical asymptotes and no holes. So those are the functions which are rational functions without any restrictions, where the domain is all real numbers, right? So keep that in mind while working with these examples. Thank you.